Hello everyone. Let us look into this very interesting problem. Okay, so it says that there is a binary tree that will be given to us, and we can paint the nodes of that binary tree in three colors: red, green, and blue. And the output to this particular question is there are two outputs. So the first output is what is the maximum number of green colors that we can use, and in the second output, what is the minimum number of green colors that we can use. And the question has to be solved under two constraints, okay, which is the vertex and its child cannot have same color, and if a particular vertex has two children, then both the children need to be of different colors. Okay, so there is a specific way in which they have given the input of the tree. So we would need to create tree out of this particular input, and we'll not immediately look into the explanation of how do we create the tree out of this, but we'll majorly concentrate on the dynamic programming part of it. Okay, so this is a tree that has been given in the question. Okay, this is the tree that's there. So how many ways we can maximize the number of nodes that are having green color. Okay, so let's see one of the solutions. So this I can make it as green. So if this is green, I can make it as red. I can make this guy as green. Again, this is a red. I can make this as green. Now this will become blue. Now this will become blue. This can be green. This can be red, and this can be green. So how many greens do we have? We have one. We have two, three, four, and five. Okay. So five is the maximum green that we can have for this particular question. Okay, so by now you would have already imagined that we have like multiple choices for any single given node. Okay, for the same given tree, if I make the tree again, uh, one, two, three, fourth node is here. If I make the tree again, I have multiple choices that I can take at any given point of time. I can make this as red. I can make this as blue. I can just make this as green. I can make this as blue, possibly red as well. I can make this guy as green. Okay. I can make this guy as a different color. So at any given node, based on the choices that we have already taken, we have different options that we can proceed with. And this is the exact nature of multiple choices at different stages is what makes this problem a dynamic programming problem, right? Because for the state could be at a node. If I have selected, let's say, green, what is the maximum that I achieve? If I select, let's say, blue, what is the maximum that I achieve? And if I select, let's say, red, what is the maximum that I achieve? Right. So every node has three options that it can be processed with. Okay, and we have to find out the maximum green that can be achieved with any of the three options. Okay, so this is what is the dynamic programming crux of this particular question. So we have already solved multiple two-dimensional problems in our course here. So this is also another two-dimensional problem. Okay, and the question says that the maximum limit is 10,000. Okay, so what we are going to have is we are going to have a variable. We are going to have a variable called int dp max. Okay, and by now you would have guessed what those individual indexes are for. So these are for nodes. These are for nodes of the tree, and this is for choices of color. Okay, so we have three choices, which is why the total count of this particular dimension is three. Okay, choices of color. Okay, now let us go assume for a moment that we have created tree, and in the end of the video I'll spend like maybe 2 minutes to explain how to create tree out of the given way of input. So but for the timing, let us assume that there is a structure that we created. Okay, the structure is struct node. Okay, so these are the nodes of a tree. Okay, struct node. This guy will have a data. Okay, this guy will have a data. This guy will have a left node and a right node. So struct node, it's a pointer to left, and struct node, it's a pointer to right. Okay. So for this question and for my video, I'll be only writing the code for maximizing the green color. You can, once you have written and once you have understood how to go ahead and write code for maximizing green color, you can simply do it for uh, minimizing the green colors as well. So that is not a problem. Okay. So now let's create a function called int maximum, or let's give it a very short name, mg, because it's a recursive function and I need to write it again and again. Okay, so what this guy will be given is a node. Okay, the current node, let's call it root, and the selection of color for this node. Okay, so I will assume that 0 is red, 1 is green, and 2 is blue. Okay, so first of all, the first thing that we always do when writing a DP is to write base conditions. Okay, so what are the base conditions here? The base conditions are if root equals to null, right? In this case, we simply have to return 0. The second base condition is if we have already solved for this problem, which is if dp underscore max, root data comma color. Okay, if this is something that we have already seen, what this means is that, let's say there was a node here. Okay, so we, for this particular node, we have already seen blue color. Okay, so if at all we come to solve this, if at all we come to solving this blue color again, we will not solve it, rather we'll use the result that we already created for us. Is not equals to -1, which means we have already seen it. We simply return dp underscore max root data and color. Okay, so now let us come to the meat of this question, which is, let's say now the color is, let's say there is a variable, we declare a variable. Okay, let's call this variable int max green. Okay, and we assign this a value of 0 to start with. Now if the chosen color, okay, if this is color chosen for root. Okay, so this root here, this is the root that we are talking about. Okay, so now color chosen for root. So if color equals to 1, okay, which means, and we have said that 1 is green, so if color is already 1, then max green equals to 1. Okay, simple thing. We have already chosen a color green, so we are increasing our max green by 1. Now comes the most interesting part. Okay, if color equals to 2, okay, let's say, it doesn't matter, the order doesn't matter, then max green plus equals to max of, so this is max. Okay, max of. Now we have two choices. So now we know that RGB, so blue color is taken. Okay, blue is taken. Okay, so what we can do is we can either give green to left and red to right, or we can give red to left and green to right. So this means that the current node is blue. Okay, so what we are saying is we can either make this as left, okay, and red as right, or if we can make red as left, we can make red as left and green as right. Okay, so there are two choices that we can take here. Okay, so let us look into both the choices. So what we'll do is here is this will become max first case when we are making green as left. Okay, so this is we are going to call this function again mg. Okay, and because green, so root, we are going to pass root dot left and we are going to give it a color of green. Okay, plus, okay, so this will come with a plus mg root of right comma 0. Okay, so this is 1 and then there is a comma. Okay, so this is 1 and then there is a comma, and in the second case we just reverse the colors. So left will be given a 0 plus mg root right will be given a 1. Okay, so simple thing. So we are having a plus here, we are having a plus here and here because we have to calculate for both of the sides what is the maximum that we get from the left side and what is the minimum maximum that we get from the right side. And all that we have done is if the color, let's say blue is already taken, then once we give green to the left and once we give green to the right, and similar for red, and whatever is the output, we just take maximum of both the trees that we can create. Okay, so this is the first condition. Okay, I am hoping that at this point of time you would have understood the next two conditions. Okay, which is, let's see. So else if color equals to 1, okay, which means green is taken. Green is taken. Okay, then max green equals to, or plus equals to, actually plus equals to max of. So we will write in, so similar equation we are going to write here. Okay, we are going to replicate the same equation, just that the colors that we would be choosing would be red comma blue. So we'll be making choices amongst these two colors. Okay, and in similar fashion, in exactly similar fashion, else if color that's already taken is, so 0 was red, so red is taken here, so red is taken. Okay, so in this case the maximum green equals to plus equals to max of. So max of, so we are going to replicate the first equation, the only difference being we are going to do it over green and blue. Okay, so this is exactly how we are going to proceed, and ultimately dp of root data comma color, the initial color that we passed, equals to max green. Okay, and we simply return dp of root data comma color. Now this is one of the function, this is one of the functions that we prepared. Okay, it is our recursive function that will create every single combination that's possible without solving the value that it has already solved. Now the question is, how do we call this function? Now if you look at the first, let's say this was a tree. Okay, if this was the tree, we have got three cases for this particular node, the 0th node. We can have this as a grid, we can have this as green, we can have this as blue. Okay, which means that when we are going to call this function, we are going to call this function thrice to begin with. Okay, and from all the values that we get from those three calling of this function mg, we are going to take maximum. So if there's a function called main, okay, if there is a function called main in which we have already taken the input string s, okay, or in which we have already taken the input string s, and we have already, let's say, created the tree. So what we have here is some root node. Okay, what we have here is some root node. So the answer, okay, so int answer equals to max. Okay, and here it is going to be mg root comma 0. So first time we give it a color of 0, and then again we will have two choices. So we are going to do another max comparison here, okay, which is amongst mg root now has 1 comma mg root now has 2. Okay, so there are a couple of learnings that we have in this particular DP1. It is important to note that sometimes the initial call that you have to make is not a singular call. There has to be multiple calls that you can make, and this happens when you have like more than one choices that you can take for the initial element. Okay, so this is what is happening here. For even for the initial element we had like three choices, so we are calling this function thrice. Okay, it could be 0, 1 or 2, and we are taking the maximum that we could have gotten out of any of the choices. Okay, the second uh, so the second is actually a very simple thing. So this by default this was looking like a two-dimensional DP. So there were two variables that were changing. One is the node, okay, one is the node and the color. Okay, so these two guys, these two variable together made a state. Okay, this made a state. So which is how we got to know that this is a two-dimensional DP, and node is obviously in the order of 10 to the power 4, because the maximum limit are 10,000, and color is of order of the range of 3, actually 0 to 3, 0, 1, 2, right? Because there are only three colors that we are permitted to take, which is red, green, and blue. Okay, so that's about this question for the DP part. Now, quick, let us spend maybe another 2 minutes understanding how to create tree, because this is a very strange way of actually giving input. I have not really encountered this way of getting input. Okay, so the way I created tree was I took a global variable called int index. Okay, and initially index was assigned a value of 0, and then what I did was I created a function called node pointer create tree. Okay, what it gets is a string str, let's say. Okay, and so what we need to do here is we need to find out the current character, which is str, and then it is the index. Okay, now we need to create a node. So the way we create a node is node, let's call it current equals to new node. Okay, and current data equals to this index. Okay, and now what we can do is we can increase index, so we can write a plus plus here. Okay, now interesting stuff here. If c equals to 2, then all that you have to do is root left equals to create tree str. Okay, and root right equals to create tree str. Okay, and else if c equals to 1, then we only can create the left node, which is root left equals to create tree str. Okay, and else we know if it is 0. Okay, if it is 0, we know that the root left equals to root right equals to null. Okay, and end of the day all that we do is return root, or maybe, yeah, so let's call this guy as root, actually root here, and So this is also root. So this function, right? This function should, I'm not sure if you're strong or weak at recursion, but this function should show you how strong recursion can be. So we simply, based on what is the current value, we were able to create our tree very easily without putting in too much of effort, right? So that's about this video. In this video, we actually saw one new way of calling the initial making the initial call to the DP function, and then we also saw an interesting recursive function to create the tree. I hope this was interesting. You have liked the video. Please let me know your feedback in the comment. Keep liking my video and please subscribe. Thank you so much.